Thank you for watching my presentation today. This will be a fundamental or introductory video about a computer science topic called machine learning. I'm looking forward to introducing you what machine learning is, what are machine learning's capabilities, and a few basic models machine learning has. Thank you for watching my presentation today. So what is machine learning, or ML? ML is an artificial intelligence, or AI, program that allows system learning and improvement based on experience and no direct programming. With information that is given, ML is a searching type of program for trends or consistent patterns that are based on inferential feedback that depend on the examples currently present. ML's focus is about making programs that can access data that will be for using and learning for themselves. And it's an overall standard for advancing problem solving with exploratory analysis and designing algorithms for using data that will be for learning and forecasting. The key for ML to operate properly is input such as training data or graphs that are based on research to get a better understanding of how to analyze data, as well as properly working domains and networking among entities. We can define our data organization with entities to work on our deep learning. We must begin our ML process with any sample data or observations. Any algorithms or experience that is direct is also welcome as another type of information. The primary objective of machine learning, or ML, is allowing systems to do automated learning instead of relying on manual input commands. With the help of automated learning, we can properly scale our commands. We instantly improve the performance and scalability of machine learning, or ML, which will bring more potential to having to do less task work manually, and that machines can be trained for better identification of patterns and relationships between data and processes. Machine learning, or ML, and AI build a stronger form of AI called hybrid AI, which is all about understanding language in data through AI. That comes with ML working with symbolic AI, which is a data processing approach that uses rules through concepts and semantic relationships. We are to keep our data secure from any cyber threats or other safety concerns, which is one of the key functions of ML. In other words, it's to protect data from being stolen or hacked. Any risky activity can be predicted using ML models for better proactivity and warnings. One of the ML or machine learning models is reinforcement. Reinforcement algorithms are an ML approach for environmental interaction through action production and either error or reward identification. This approach of reinforcement ML allows systems and software to choose the most suitable trend or pattern through automation within a specific context. Reinforcement ML helps keep the performance of algorithms at a much greater rate. Reinforcement signal is defined as an easy reward feedback, which is needed for software to learn the most ideal choice of action. Overall, the most important qualities of reinforcement ML are trial search, error search, and delayed reward. Our second ML algorithm topic we will introduce is supervised ML, which are a type of algorithms that apply what has already learned, or in other words, we apply past learning to new data. And data will be used with labeled examples for event predictions. Analyzing a known training dataset takes place with the algorithm making a functional inference to make result predictions. The system can make targets available for new input after sufficient training. The real results may be compared with results that were intended to determine possible sources of error and if we need to modify the model when necessary. Overall, the key with supervised ML is to lower the bias as much as possible with better control. The last of the machine learning model topics we will discuss is unsupervised machine learning, which are algorithms that are for training unclassified data with no labeling. Unsupervised machine learning does investigations for how systems can infer functionally for structured descriptions that are secretly revealed from non-labeled data. The system does not know the specific correct results. Instead, conclusions that are inferential are drawn from the datasets that are based on the expected results. Overall, the instant performance and great flexibility to adjust is what defines unsupervised machine learning. We went over the fundamental computer science topic of machine learning. We discussed what machine learning is in terms of computer science, what strengths machine learning possesses, and what are the different basic machine learning models. My personal goals from machine learning would be to learn Python as a primary programming language, to master big data, starting with learning Hadoop, Hive, and Spark in the Apache Software Foundation, learn file text analysis with the NLTK, or Natural Language Toolkit. And finish off, I would like to build a personal portfolio learning a lot of statistical programming techniques. this wraps up my very first fundamental computer science topic of machine learning. Thank you so much for watching my presentation today. I sure hope that the topics discussed in this presentation have come in helpful and handy, and I look forward to expanding further in detail of the many topics discussed in this presentation. And till another presentation in the future, thanks again for your time, and I hope you have a wonderful day.